For half a century, the moon has hung in our sky as a silent, unvisited monument to a bygone era of courage. The Apollo program proved that humanity could reach another world. But the spirit of exploration demands more than a visit. It demands a presence. Now, the torch is reignited. We are not just returning to the moon, we are building a permanent foothold among the stars. This is the Artemis Program, named for the Greek goddess of the moon, the twin sister of Apollo. This time, we go to stay. The Iron Will, Space Launch System and Orion. The journey begins with raw power. To escape Earth's gravity well and reach deep space, NASA forged the most powerful rocket ever built, the Space Launch System, or SLS. Standing taller than the Statue of Liberty, the SLS is the heavy lift vehicle designed to shatter all previous records for thrust. It is the necessary titan to hurl the next generation of deep space vehicles toward the moon. Crowning this giant is the Orion multi-purpose crew vehicle. Orion is the only spacecraft built for human flight capable of sustaining a crew in deep space, protecting them from the lethal radiation environment, and returning them to Earth at the blistering velocities required for a lunar return. Tested successfully during the uncrewed Artemis I mission, Orion's heat shield withstood temperatures approaching 2,760 degrees centigrade 5,000 degrees Fahrenheit, a trial by fire that certified the capsule as humanity's lifeboat back from the cislunar void. The stepping stones, Artemis I and II. The return is a phased, deliberate march. Artemis I established the foundation, an uncrewed shakedown cruise that sent the Orion capsule thousands of kilometers beyond the moon, validating the rocket, the spacecraft, and the complex maneuvers of deep space navigation. It was a flawless rehearsal that set the stage for the true commitment. Next is Artemis II, a historic crewed flight around the moon, carrying 4 astronauts farther into space than any human has ever ventured. This is the critical test of Orion's life support systems and the crew's ability to operate in a true deep space environment. They will perform a lunar flyby, using the moon's gravity to slingshot back to Earth, a hybrid-free return trajectory. For the first time in half a century, human eyes will witness the awe-inspiring sight of an Earthrise from lunar orbit. The landing site, the lunar South Pole. The destination for the landing itself, Artemis III, is not the familiar lunar equator of the Apollo missions, but the enigmatic and resource-rich South Pole. Why the South Pole? Because here, within the perpetually shadowed craters, scientists have confirmed the existence of water ice. This water is the key to sustained lunar presence. It can be mined for drinking water, but crucially, it can be broken down into its components, hydrogen and oxygen, to create breathable air and, most importantly, rocket propellant. The moon is being recast as a literal gas station and outpost, where future missions to Mars can refuel, drastically lowering the cost and complexity of deep space travel. This is the paradigm shift. The moon becomes a proving ground, a vital springboard to the Red Planet. The architecture, gateway and HLS. A new space architecture is being woven into the fabric of cislunar space. The Lunar Gateway is a small, modular space station that will orbit the moon in a stable near-rectilinear halo orbit. It will serve as an orbital staging point, a science laboratory, and a communications hub for surface missions. Astronauts will not land directly from Orion. Instead, they will dock with the Gateway and transfer to a specialized vehicle, the Human Landing System, HLS. The HLS, a massive, vertically integrated lander like SpaceX's Starship HLS, is designed to take 2 astronauts to the lunar surface for an extended stay, and then return them to the Gateway. The reliance on commercial partners for the lander signals a new, collaborative era in space exploration, leveraging private innovation to achieve public goals. Sustainability and inclusivity. Unlike Apollo, Artemis is not a race, it is a long-term commitment. The program aims to establish Artemis Base Camp on the lunar surface, a permanent habitat capable of supporting rotating crews for weeks or even months. This extended presence will enable profound scientific discoveries, from seismology to space weather, transforming our understanding of planetary formation. Artemis also carries a powerful social mandate, to land the first woman and the first person of color on the lunar surface. This commitment to inclusivity ensures that the next giant leap for humankind is taken by all of humankind, reflecting the diverse world that looks up at that shared cosmic beacon. The moon is no longer a finish line. It is the beginning. The towering rocket, the resilient capsule, the permanent orbital station, and the brave new landers are all steps in a plan that stretches far beyond our nearest neighbor. The lessons learned in the extreme environment of the lunar South Pole, how to live off the land, how to shield ourselves from deep space radiation, are the vital rehearsals for the voyage to Mars. Artemis is the first sunrise of a spacefaring civilization, establishing the foundation for our eventual exodus to the Red Planet, and lighting the long road home for all future generations. For the next chapter of Cosmic Vanguard, we will look beyond the moon and the Artemis program's immediate goals to explore the ultimate destination, Mars colonization, and the technological challenges of making the Red Planet habitable. For millennia, we have gazed up at the night sky, seeing only pinpricks of light, ghosts of the past. But humanity's deepest drive is to know the unknown. We built monuments to our vision, and now, we have built a new eye for the cosmos. It launched not with a scream, but a promise. The James Webb Space Telescope, folded like a colossal origami, ascended beyond the veil of Earth's atmosphere. Its destination, a million miles away, at the gravitational sanctuary of Lagrange Point 2. It is here, shielded from the sun's heat and light, that Webb began its deliberate, meticulous unfurling. A sunshield the size of a tennis court, 5-layer membranes thinner than human hair, deployed to keep the primary mirror perpetually colder than liquid nitrogen. This was not a quick journey, it was a deployment of patience, a flawless execution of engineering that defined the next generation of discovery. Unlike its predecessor, the venerable Hubble, Webb does not merely look at the visible. It peers into the infrared spectrum, the heat signature of the universe. This is crucial because, as light travels across billions of years, the expansion of space stretches its wavelength, shifting visible light into the infrared. Webb is, in essence, an archaeologist of the cosmos, designed to capture the faint, red-shifted glow of the very first stars and galaxies, structures that formed only a few 100 million years after the Big Bang. Webb has given us images that are not just photographs, they are emotional experiences. Take the familiar pillars of creation. Hubble showed them as majestic, but Webb reveals the turbulent, dusty heart of their star formation. Its infrared sight cuts through the opaque cosmic dust, unveiling the newborn protostars tucked within the towering nebulae, illuminating the foundational processes of stellar life and death that were previously hidden from our view. Its mission extends beyond deep space. Webb is revolutionizing exoplanet science. It uses the transit method, watching a distant world cross its star, to analyze the starlight filtered through the exoplanet's atmosphere. This process allows scientists to detect the molecular fingerprints of gases, water vapor, methane, carbon dioxide. These are the potential biosignatures, the telltale chemical signs that hint at the possibility of life far beyond our solar system. The search for another Earth is now more forensic, more immediate than ever before. Webb is more than a telescope, it is a time machine, an instrument of profound curiosity. It is teaching us that the universe is richer, more violent, and far more beautiful than we imagined. Every flash of distant light captured on its segmented gold mirror is a fundamental challenge to our current models of cosmology. We stand at the precipice of breakthroughs that will redefine our place in the galaxy. The new site is open, and the universe has begun to speak. For the next episode of Cosmic Vanguard, we will leave the deep field to explore the immediate future of human presence among the stars, the Artemis Program and the return to the Moon.